welcome back to this amazing channel. This is Abhinav. From last 2 years, I'm making these video editorials of Codeforces, Codechef and Leetcode contest. And you guys have shown a very great support in my videos. So first of all, thanks a lot for that. And these regular CP contests, participating and practicing these questions helped me also to crack good companies like LinkedIn, Zeta, and Geeks for Gigs. And this all was possible because of a proper mentorship and because I solve these problems regularly. I do upsolve the problems and I do solve problems of lead code and code force. So if you're also someone who is preparing for CP, who is preparing for interviews, who is searching for internship, but facing difficulty with you are not able to increase your rating, you're not able to solve problems regularly. If you are facing any such difficulty, we have recently launched Coding 75 Pro, where we provide one-to-one mentorship sessions and live classes of CP contest discussions, DSA classes, live project building classes, and CS fundamental classes. So it's a complete pack of your interview preparation. So if you are watching this video editorial of Codeforces, Codechef, and Leetcode, and if you want to also join the live discussion of these same contests with me, along with that, if you want one-to-one mentorship with me on CP, on DSA, on interview preparation, or in general anything that you need, you can check out the Coding 75 Pro subscription. The link is in the description. The whole schedule of the course is also present in the description. You can check that. The cost is very efficient, just $499 per month. That's it. But if still you have any doubt regarding our Coding 75 Pro subscription and how it can help you can DM me on my WhatsApp number, which is given in the description. You can DM me directly. We will talk about what are the difficulties that you're facing and how Coding 75 Pro can help you. So do join it now. Thank you.
Hello guys and welcome back to this amazing channel. This is Abhinav. Today in this particular video we'll discuss about the 4 problems of Leetcode weekly contest 937. Yes. So for 937 we'll discuss the 4 problems of this contest. The first 2 problems A and B were pretty easy, but the problems C and D were of good level. Okay, so we'll discuss all of 4 here. These are the 4 problems actually. Let's first discuss the problem number 1, which is permutation difference between 2 strings. So the problem is very clear that we have 2 strings which are permutation of each other. For example, if the first string is, let's say, coding. Okay, this is, let's say, the first string. Okay, so the second string will be the permutation of this. Means the same characters will be present in different order. Okay, so this is S, T will be like this. Let's say D, G, I, N, like this. Okay, so if you will see, this is the permutation of the above string. Now you have to find the difference of the permutation. Difference between basically is the difference between the indexes of each character. For example, if you will see, let's talk about character C. So character C is present 0 times at index 0 here and at index 3 here. So what's the difference? Difference will be 3. 3 minus 0. Similarly, character O is present 1 here and at 4 here. Again it will be 3. 4 minus 1 is 3. It will be absolute difference, right? For D you will see it is present at index number 2 here, 0 here. It will be 2. For I is present at index number 3 here and 2 here. It will be 1. N is present at index number 4 here and 5 here. Again 1. And G is present at index number 5 here and 1 here, means 4 is the difference. So you have to find the sum of this whole difference. Just like here it will be 3 plus 3 plus 4 and it will be 14. That will be your answer. That will be your answer, right? So if you will see what I have also done it, I have used the unordered map. So basically I have used this unordered map to store index of each character in S1 string also and in S2 string also. Basically in S and T also, not S1, S2, S and T. If you will see in this S1 map, I am storing that for a particular character at which index it is present, and for T2 I am storing that for string T, that which character of string T is present at what index, right? Is present at what index. Cool. Now the answer will be the sum of the absolute difference between the character index of a character in string 1 minus the index of same character in index 2. So see, if you will iterate through this S1, means this map 1, so second element of this map 1 will be the index of the character in map in string in S. Okay, minus you have to find the same characters index in string T. For that you will first take that character which is x dot first and you will find its index in T1 string. Okay, so and you will find the summation of all the absolute differences, right? So this was a pretty easy problem. We have solved it using unordered map. But still, if you have any doubt, you can ask that to me in the comment section, and you can also join our Telegram channel for any of this doubt. Plus, if you want to join me in a live discussion of this Leetcode contest, you can actually check the description. I have provided a link. In the evening, we will have the live discussion of this contest, right? Cool. Let's move forward, guys, to the next problem. So next problem is actually, yeah. So next problem is actually taking maximum energy from Mystic Dungeon. This was a good problem. It was actually a brute force problem, right? If you will see the constants now, so the length of this energy array is just 1000. That means we can actually solve this problem in order of n square time complexity, right? Let's see how we can do that. So basically they are saying that there is some array given to you. The array defines the energy that you can get from a magician. If the energy is positive, that means you will get that much energy from the magician. And if the energy is negative, that means you have to give that energy to the magician. Means that energy will be gone from you yourself, right? That's the basic thing. The thing is, you are cursed in such a way that after absorbing energy from magician 1, that when you will take some energy from magician 1, you will be instantly transported to magician I plus k, and this process will repeat until you reach I plus k. Okay, let me tell you the example. Thing is, for example, if the array is like this, let's say 5 1 minus 3 2 minus 8 minus 7 6 1 minus 9 2 0 5. Let's say this is the array. Okay, अब in this array, for example, that the value of k that you are having is 3. Okay, so now let's say, now you can start from any point. Actually, you can start from any point. Let's say first case that you started from, let's say, index number 1. So if you will start from index number 1, you have to take this one, and along with this one, you have to also take 1 plus 4, then again a jump of 3, then again a jump of 3. This will always be taken. You cannot skip any of the between. You have to take them. Let's say you started from 5, index number 0, then you have to take like this. Like this. After this, it cannot go. If you will start, let's say, from index number 2, then it will go like this. It will go like this. 2 plus 3, 5, 5 plus 3, 8, 8 plus 3, 11. Okay, so this is how you have to go. And it's not like that you can just start from some initial index. You can start from somewhere middle also. Okay, you can start from somewhere middle. For example, let's say initial all the values are negative. Let's say this is also negative, this is also negative, negative. They all are negative. So when these initial values are negative, you will not start from here. Na? They all are negative. You can maybe start from here and then jump and then jump. You can maybe start from here. So you can start from any middle point. You can start from any middle point, right? If you will see one thing here, the value of k is actually equal to energy. So like your problem can be equal to that only. You can go up to energy length also, and then okay. The thing is, I think said it wrongly before. The length of the energy array is actually 10 to the power 5. It is 10 to the power 5. So you can actually not write your solution in order of n square time complex. That is not possible. Because see, if you will do like this, then your solution will be order of n into k. It will be order of n into k. How it will be order of n into k? Because first you will start from here and you will take next k. Then you will start from here, then you will take next k. You will start from here, you will take next k. Then you will start from here. So for every index, you will try to start your loop. You will try to start your loop and you will go on. Okay, it will be little costly. So it will not be n into k, it will be actually c. Let's say if you started from my index, you will try from every index, right? You will start from here, you will try to start from here, you will try to start from here, from here, from here, from here, from here, from here, from everywhere. Okay, this will cost you order of n because you will try to start from every index. This will cost you order of n. Next is when you will jump k steps, you will actually take n by k steps for each index, or we can say I by k, it will be simpler. So overall time complex will be order of n square by k. Kaise? First you will take a for loop of I from 0 till n, and now for every I you will take a j starting from I, and that j will jump to again kkq. So overall time complex will be order of n square by k, which will be very large. You cannot go up to n square. So what you can actually do here, we can have a better option. Instead of starting from every index, what we can do is now, see, if you will, let's say, start from here, it will go like this. If let's say you started from here, it will go like this. But if you see, wherever it is starting, that doesn't matter. But this will end always, like this range will always end in the last 3 or last k numbers. It will always end at the last k number. Let's say if you will start at -9, it will end at 5. If you will start at -7, it will also end at 5. If you will start at let's say -2, it will end at 2. If you will start at 6, it will end at 2. So you can start from any of these middle numbers, but it will end in any of these three numbers itself. None other than this. It will definitely end in any of these three numbers. So what we can do the same thing from the back. What we can do, we will say, okay, let's first start from 5. When we're starting from 5, we will make a jump. What's the sum here? Up sum is -9 plus 5 minus 4. Means let's consider this much part. This much part means when you will just start from here and we will go to 5. Then take one more step. Now this is the case when you are starting from -7. Then let's take this step. This is the case when you are starting from -3. So again and again you have to not make new calls. In this one call from 5 to -9, then -7 and -3, all the cases are covered. All the cases are covered where 5 is ending. Similarly, start from 0, then 1, then -8, then 1. Similarly, start from 2, 6, like this. So we start from back only, and we'll go -k, 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 and for every step we will take the maximum because we want the maximum value, right? So if you will see, what I'm doing actually here is, I'm first taking a loop from 0 to k, because for last k I have to go. For every k, if you have like any doubt here, you can do with that thing. You can say, okay, I will start from index -1, means this last index. I will start from there, and I will go up to where? I will go, sorry, it should be greater than -k. So यहाँ तक जाओ, right? Means you will start from, let's say, 11, then 10, then 9. 8 you will not. So means you will go up to greater than 11. 11 minus means 11 minus k. Okay, and you will do minus here. Okay, you will do minus here, and then you can start your j from I. So if you will see what I'm doing, my I starting from the back of the array is going 11, then 10, then 9. Like means you will try to start from here. Okay, and then from every I am starting my j loop, which will go up to the start of the loop, and every time it will decrease k, and whatever is the sum, we are finding maximum of it. Okay, so this is how actually you can decrease the time complexity. How? If you will see, this loop will run only k times, and this will actually run n by k times, because in a in a gap of k it is going now. So overall time complex will be k into n by k. K into n by k. It will be order of n only, which can be done. Previously it was order of n square. That is why we are going from the back side. We are not going from the start, right? That's the very first thing. Amazing. Ye ho gaya. Let's move forward now. Still, so if you have any doubt, guys, now regarding this first two problems, you can ask that to me in the comment section. Okay, and guys, if you guys wanted to have live discussion with me on all these problems, you can actually check out the Pro of Coding 75, where we do live discussions of all the Leetcode, Codeforces, and Codechef solutions. So today evening we have the live discussion of that. You can check that out. Cool. Next is maximum difference score in grid. This is actually a good problem. So this problem is actually of dynamic programming, but with some extra logic, we are solving this problem. Okay. And the problem is very basic. Problem says that you have a m into n matrix. Okay. Now what you can do, you can start from a cell and you can move to any other cell which is either in the bottom or either in the right side of it. And when you will move to that cell, the score that you will get will be the difference between the C2 minus C1. Let's take the same here. Okay. If you will see this, so here, let's say you are currently at this cell. Okay. You are currently here. If you are going here, the score that you will get will be 6 minus 9. Or either you can go down, it will be 7 minus 9. So you can get any of those scores. Right? You can get any of those scores. Amazing, amazing. Now you have to, what you have to find, you can start from any cell. That's the main point. Mostly in grid problem, what happens is that you have to start from here and you have to go here. This, but no. Here they are saying you can start from any cell and you can take at least one move. It's also not required you have to reach the end. No, not required. You can start from any cell and you can take at least one move. So how we can actually solve this problem? See guys, first of all, we will write a very basic recursive code for solving this. What will be recursive code? If you know the very basics of DP, you will understand. Okay, if I will write what I am doing here is, let me write the code here. So before moving forward in the video, let me get a chance to tell you guys about Coding 75 Pro, where we conduct live DSA classes, weekly project sessions, CS fundamental classes, one-to-one mentorship and resume review sessions. Also, you will get a chance to join our pro community where you can interact with other coders and students like you. So overall, it is a complete plan for your interview preparation. This all is just at the price of less than 20 rupees per day. So you can join this Coding 75 Pro by visiting our website coding75.com, and then we will crack great companies together. So if you will see, this is my code. I will make this little smaller. Cool. So this is my code, okay, and this is, let's see, the thing. Now look what I'm doing in this code. In this code, I'm saying, okay, let's say if I'm starting from I and J. Let's say if I'm starting from I and J. Okay, so what is the maximum? What is the maximum score that I can get? What is the maximum score that I am get? This I will tell. Okay. Okay. Ab dekho, what we are doing here is, let's say we are here, we have to solve. When you're starting from I comma j, we have two steps. Either go to I plus 1 comma j, either go to I minus 1, I minus I comma j plus 1. So I'm checking both the things. Okay, let's for now forget about this DP. So this is a base case, because obviously if I will become more than the number of rows and if j will become more than the number of columns, you will return 0. That case will not be taken. Else what you will do is, you will take both the cases. If I plus 1 is in the range, what you will do, you will try to go to I plus 1 comma j. So you will make a recursion call for I plus 1 comma j, and when you will move to I plus 1, what will be the cost that you will get? The cost will be grid of I plus 1 minus grid of I, the difference. Same if you will try to go to j plus 1, if it is in the range, then cost will be j plus 1 minus j and plus solve for j plus 1. Okay, and to take the overlapping case, I am using DP. This is a very basic DP code that I have written here. Okay, so for let's say I'm starting from this is 0 1 2 3 0 1 2 3. Let's say I'm starting from 0 comma 1, which is having a value 5. From the 0 comma 1, I will either go to 1 comma 1 or either go to 0 comma 2. So when I will go to 1 comma 1, so this is 0 comma 2, this is 0 comma 1. From this, if I will go to 1 comma 1, the difference will be what? 9 minus 5. So I will add 4 in my case. 4 will be the difference that will be added. But if I will go to here 0 comma 2, then difference will be 7 minus 5, which is 2. Okay, means when we are going from 0 comma 1 to 1 comma 1, we are getting 4 as the score, and when we are going from 0, 1 to 0, 2, we are getting 2 as the score. That is what we are adding here. And then again for this 1, 1 and 0, 1, I will make the recursion call. That is fine here, right? This is a very basic recursive DP plus recursion code, which is actually fine that from a point, if we will go on, what's the maximum that we can get? Okay, what's the maximum that we can get? I think we have to find here the we have to find maximum. Sorry guys, not minimum, maximum of it we have to find. So we'll find the maximum of it, right? Amazing. Now what we are doing is, this is not sufficient. In most of the cases, what you will do, you will say, okay Abhinav, this is the solve function. I will call this solve function for 0, 0. Means I will start this solve from 0, 0 itself. But no, here you cannot actually start it from 0, 0 because they are asking us that you can actually start from any cell. So function will be same, this DP function will be same, and if you will see, what I'm doing is I'm taking a loop of n into m, means for every cell, and what I'm doing is that for every cell I am actually calling this function. I'm actually calling this function for every cell, means I'm starting my start journey from every cell. I'm trying from every cell. I will first try to start from here. I will then try to start from here, then here, then here, then here. For every cell, I will start this. I will call this solve function, so that that case should also be handled, right? Up next, you will always say, Abhinav, like this time complexity of this solve function kitni hogi? It will be order of n into m, right? Because dp size is n into m, and you are calling this function again n into m time. So time complexity will be very large. It will be n square into m square. No guys, it will be still n into m only, because obviously when you are calling this function for I comma j, and when for the same I comma j it will be called again, it will not again calculate the value. It will simply return the current value of dp. So overall, the function will run until the dp is filled, and dp is just of size n into m. So time complex will be n into m only. But one extra case you have to handle here. The case is, in this DP array, every time when you are considering a move, let's say from I to I plus 1 or j to j plus 1, then you are again making the next call of recursion. Means you are making more than one call. You are not handling a case where you can have just one call. They are saying that you can also have at least one call. For example, what I will do now, from this 14, I will just go to 3. So kitna ho gaya? Or let's say from this 7, I will go to 14. So how much will be the score? The score will be 7. Maybe this is the maximum score. Maybe. Or let's say this is a simple, very simple grid. Let's say the grid is like this. Up in this grid, let's say everything is, let's say here it is 9, 1, 1 and 1000. But in this case, what you will do? You will not start from 9. No. Because if you will go anywhere, it will give a negative score. But you can simply start from 1 and go to 1000. It will give you 999. So maybe in some cases, we have to only take one single step. That is sometimes not handled in this DP. So for that one single step, I'm actually taking a different variable max I1, which is just considering single steps. So every time for I and j, I'm taking that if I will go to I plus 1 and if I will go to j plus 1, just single step. That from this I to I plus 1, from that j to j plus 1. Then what will be the score I will get? And I'm finding the maximum of all such scores. Finally, my answer will be here. So my answer will be that if max I is 0, means, अब देखो ये चीज में देखो अब इसमें there is a confusion also. The thing is, see, that will be actually taken here. The single steps will also be considered in this grid. That is also fine. The problem comes when we will return this max I. Maxi I will be returned. Maxi I1 will be returned when this maxi I will give you 0. And when it will give you 0, let's say all the possibilities are, let's say, negative, then this will give you 0 because we are finding max of 0. When it will give you answer 0, that means all the so see, let's understand different. See, I said one thing wrong. The wrong was, I was saying that this db function will not consider the single step. So the thing is, it will consider a single step. But the problem will come in a case. The problem will come that, let's say, if we are having a grid, where every move is negative, where every move is giving you a negative, score, where every move is giving negative score. Let's say here, in this grid, if you will see, if you will go any move from 100 to 5, 100 to 5, 5 to 1, every move will give you negative score, right? अब in this case, what will happen? Your DP function will give you answer 0. Your DP function will give you answer 0. But 0 means it will say like don't take any step because all the steps are negative. In that case, what you will do, because you have to take at least one step, you cannot take 0 steps. You have to make at least one step. Then you will take the step which is least negative. सबसे कम negative. For example, here 5 minus 100 was minus 95. That is not good. But we can go for 1 minus 5, which is least negative. So that is what we are finding here, right? So if our max size 0 means our DP function is saying don't take any step, all are negative. So return the which is the least possible negative, else return the max size. Okay, so that I confused while explaining that. Okay, this is why we are handling it separately, right? Amazing. So I hope that you have got the understanding of this problem. Again, if you have any problem regarding this particular solution, you can ask that to me in the comment section, or you can join the Telegram channel and you can discuss it there. Okay, amazing, amazing, amazing. Let's move forward. Next, the last problem of this particular contest, which is maximum cost array. This is actually a very good problem. This problem says that you are having a first of all a number, a nums array. Let's say the nums array is like this. And one thing, yeah. So this nums array is also actually a permutation from 0 to n minus 1. Let's say nums array is like this. It is of size 6 and it has numbers from 0 to 5. Okay. Now what you have to do is you have to find a permutation array. Again, a permutation array will be a array from 0 to 5 having some permutation. It can be any array. Let's say the array that I've chosen is 0, 5, 1, 3, 4. Now what you have to do is you have to find this PEM array in such a way such that the value of this, what is this, yeah, it is permutation of 0 minus nums of permutation 1, permutation 1 minus nums of permutation 2, plus this should be maximum possible, sorry, this should be minimum possible. Yeah, this should be minimum possible score. Now how we will actually do this? See, first of all, permutation 0 is 0 minus nums of permutation 1 minus nums of permutation 1, right? What is permutation 1? Permutation 1 is this, plus permutation 1, or sorry, so I did one mistake. So 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. Huh. What I'm saying, initially first of all I will take permutation 0 minus nums of permutation 1. Permutation 1 is 5, means nums of 5, which is 2. Are you getting? Then next is permutation 1, which is 5, minus nums of permutation 2, so means nums of 1, which is 0, plus permutation 2 minus nums of permutation 3, which is 2, 5. Okay, this is what I will do till the end, and you want the minimum value of this. You must be asking, Abhinav, how we can do that? You will think, okay, Abhinav, what I will do now for 3, I will make 0, means for every number you will take the maximum possible number, or the number which has the maximum difference. But actually, guys, there is no as such greedy or as such optimized solution for this problem. Okay, there is a problem for bit and all of that, which will be very complex. So the very basic way to solve this problem will be backtracking. Backtracking or recursion means checking for all the possible problems, checking for all the possible permutations will be the good approach for solving this problem. Why? Because if you will see the constant of this problem here, the length of the array is just 14. So you can actually solve this problem using 2 to the power n time complexity, means you can actually solve this problem using basic brute force backtracking. Yes. So means for this nums value, I will check for every combination of this permutation from 0 to n minus 1. And for every permutation, we will check which will give you maximum, or sorry, minimum value. And that permutation will be the answer. Because that is the only way to solve it. Because why? Why that's the only way? Because you have to also find the permutation. You don't have to just find the minimum value. You have to find the permutation with the minimum value. So we have to actually do backtracking. If we have to find just minimum value, then maybe it is possible to do that. But because we have to find permutation also, we have to actually check for all the permutations and perform backtracking. So see how I am doing it. Okay, how I am doing it is, let's say that there is a nums array 1 0 4 3 2. ठीक है. अब see guys, in the perm array I will initially take a 0. ठीक है. I mean initially take, because see 0 you can take with any number, because 0 with any number will be a good difference. It will not make less or more difference. ठीक है. आप 0 से 1 को ले रहे हो तो it will be positive difference only. By the way, you have to take absolute value only. अब हाँ, what you cannot take, you should not take 4 with 4. You cannot take 3 with 3, because if they will subtract it will make a problem. So what I'm doing is, guys, if you will see here, this is the find permutation function. In this find permutation function, we have the nums. I've taken two things. This is the minimum value. This will actually store the answer, that how much minimum value we can actually get. This is the answer. It will actually store what is our answer, permutation, which is actually giving us the minimum value. We will store here. Now, we will first have a used vector. This vector will basically tell us which indexes we have used in our permutation, because we can use every index only once. So because when we will create the permutation, we will only use every index only once. Okay, and that will be of size this only, nums only. Now, as I told you, initially in my permutation I will take 0. 0 can be taken anywhere. So I will start with 0 and I will make use of 0 equal to 1. Now starting from 0, I will call the backtracking function, and when this backtracking function will be executed, after executing, it will actually store the permutation with the minimum value in the answer, and you will return the answer. Now let's discuss the main function, which is the backtracking function. Okay, अब in this backtracking function, what is happening is, if you will see, first I am saying that if the current sum, the current backtrack that you are going on, the current backtrack, the current recursion call when we are going on, if the sum in that recursion call is greater than the current minimum value. What is the current minimum value? Current minimum value will tell you that, okay, you have already got a permutation which is giving you that value. For example, you have got a permutation which is giving you a minimum value of 100. Now if you are making a recursion call where the sum became more than 100, then no need to continue that recursion call, because if sum became more than 100, we already have a better option of 100. Don't go that. So whenever sum will become more than minimum value, we will return. Next, there are two cases. First case will be that if the permutation size is equal to num size, means the size of this permutation array is equal to nums, means it contains all the numbers from 0 to n minus 1. Then what we will do? No, let's not talk about this base case. Let's discuss about this case. Okay. Now, guys, the thing is that for now, let's say currently we have 0 in our permutation. Next, which number should be taken? Next, which number? It can be 1, it can be 2, it can be 3, it can be 4, it can be anything. It can be any number between this. So what we will do, we will check for every number. We will check by placing every number here. We will check by placing every number here. We will try to place 1 here also, 2 also, 3 also, and 4 also. 4 also. So what we will do, let's for now skip this. Let's discuss this. What I am doing, I am starting my array from this loop from 0 going up to n minus 1. This is n and I plus 1. And for every number which is not currently present in that particular permutation, means which is not used. For example, here in this case 0 was used. Apart from any number, apart from 0, 1, 2, 3, 4 are not used. For that number I, let's say I is 1 currently, it will use it. It will insert in the permutation. Let's say like this. It has inserted in the permutation. Okay. Now it will make use also true, that you have used it. And now for that number, it will make the backtracking call. It will make the backtracking call. Nums, use, and perm. Now, when we make the backtracking call, see, if you have taken after 0, when you've taken 1, that means you must be adding some, what? You must be adding some score also in the final sum. Let me change this a little bit. You must be adding some score also. So when you're having 0 and 1, what will be the score? Score is permutation of 0, which is 0, minus nums of permutation of 1. So permutation of 1 is 1. It means nums of 1 will be 4. So value will be 0 minus 4. So that will be added in the sum. What will be added? The last second value of the permutation minus the last value of permutation ka nums wala value. Means nums index of the last value of permutation. That will be your new score that will be added in the sum. तो आपका sum में add हो जाएगा as people will go. अब मान लो you have taken 0 and 1, you got the score as 4. अब from 1 let's say you taken 4, next came 4, तो इसका क्या होगा? What? Nums of permutation size minus 2 means nums of 1, permutation of 1 minus nums of permutation of 4, which is 4. Nums कहाँ पर है? Nums 4 will be 2, so means 1 minus 2. That will be added, and so on. And once up, let's say you taken 4 and 2 and 3, once this will be stopped, it will backtrack. So you can see after making every recursion call, we are backtracking. Backtracking means we are again popping that value from the permutation and again making is use equal to false. Means we have used 1 here. Now I've removed that 1. Now I will try for 2. Then I will try for 3. I will try for 4. Just like simple, if you have solved problems like rate maths, Sudoku solver, you must know this fundamental of backtracking that we are doing here. And whenever the last number is inserted inside the perm, means the size of the permutation is equal to the size of the nums, then we will simply find the difference between the last value of perm minus nums of perm 0. That is what given here also, if you will see. So let's say that if you will taken 4, let's say you have taken 4, after 4 you have taken 3, then 2. So value will be perm of last 2 minus nums of perm 0, which is 0, which is 1. So this is what you will do. And then once you have all the values in your perm, now simply check that if the current sum, means the sum of the current permutation, is less than the current minimum value, make minimum is equal to sum and make that permutation as your answer, because that is giving you the minimum value. That is giving you the minimum value, right? So guys, I hope that you have got the understanding of this particular problem. If you still have any doubt, please ask that to me in the comment section, or you can join my live discussion today at Coding Simplified Pro. Details in the description. Okay, cool guys. Thank you for watching this particular video. The problems were actually good of this contest. I can understand the last problem was really difficult, but I hope that you have got the good understanding of these problems. Thank you.